worksheet 3.3, this is the one about ions. Now, what are ions? Okay, well, first of all, we know that for atoms, there we go. We know that for atoms, the number of protons equals the number of electrons. But that's not true for ions, though. Ions have a different number. Protons do not equal electrons. Okay, so for 3.2, it was like, hey, if you had 20 protons, you had 20 electrons, because the atoms, that means that they're neutral, that the number of plus charges equal the number of negative charges. But that's not true for ions. Take a look at our first example. Our first example here is sodium with a +1. Now, here's how I like to think of that. I'm going to write this up top here. Sodium with a +1. If you see just a plus sign, that means +1. If you see just a minus sign, that means -1. Because a lot of resources will use the shorthand of just a plus and a minus. So what does it mean when sodium has a +1 charge? What it means is that there is one more plus charge than there is negative charges. I'm sure, I know that's not earth-shattering, that you're like, oh my God, well, that just illuminated everything, Mr. Bensing. So no, of course, that didn't. Let's start from scratch, though, and see if we can figure out what's going on. And what I mean by start from scratch is take a look. First of all, I look on a periodic table for the atomic number of sodium, because that's on every periodic table. You look for Na, and the number that's in there, the whole number that's in there for sodium is, of course, that is number 11. And that means that the number of protons, these two are equal to each other. Atomic number, number of protons are always the same. Now, I'm going to cross this off. I'm going to automatically, I'm just going to get rid of atomic mass, because atomic mass is suggesting that I would write in here 22.9898, or whatever the number is. For this one, it says 22.9898 on my periodic table. I hate that. I hate atomic mass there. It actually, in my opinion, should be mass number. And one of the ways that we can estimate mass number is to look at the atomic mass. I know what you're thinking. I just crossed off atomic mass. But I look at the atomic mass, and if it's 22.9898, then I round up to 23, which is what I put here, like that. Now, why would I do that? Why would I round up atomic mass to get mass number? I do that so I can find the number of neutrons, because the number of neutrons is simply the mass number minus the number of protons. So that means that what I have here is minus 11, and that equals 12. 12 neutrons here. So the real question is, how many electrons do I have? Well, here's the deal. The number of protons minus the number of electrons equals the charge. So if I have more electrons, I have a negative charge. Say I have hydrogen, but hydrogen has 2 electrons instead of just 1 when it's, an atom. It has an extra electron. It looks like helium. And 1 minus 2, of course, is a -1. That means hydrogen has a -1 charge if it has 1 more electron than it does proton. Okay, now here is how I'm going to find the number of electrons. I simply, if I'm solving for this equation here like this, I simply take the charge, I already screwed it up. The number of protons minus the charge is how I find the number of electrons. Okay, so protons minus charge. What does that mean for sodium? Well, that means that I have 11 protons, and I'm going to subtract a +1. That doesn't look right. Let me try that again. Subtract a +1. There we go. What does that equal? Well, 11 minus a +1, of course, equals 10. You're going to see some of the same numbers in the number of electrons. You're going to see it happening over and over and over again. So let's take a look at the second one. Let's see if I can go through this one just a little bit quicker. You look onto a periodic table. Chlorine is number 17. That's 17 protons, so I can fill these two in because these are always equal. If I round off chlorine, a 35.45 blah, 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 is 35. Look on a periodic table. The atomic mass is 35.45. I round it off to 35. The number of neutrons is 35 minus 17, which is 18. Good. And the number of electrons is 17 minus a minus 1. I wanted to show you one with a negative charge here so I can show you what happens. 17 minus a minus 1, go ahead and put that in a calculator. What you will notice is that it gives you the number 18. Almost like you can change both of these to pluses. 17 plus a plus 1 is, of course, 18. When you have two negatives, let me rewrite that so you can see that. Minus a minus 1, when you have two negatives, 17 minus a minus 1 is exactly like 18 because you can make that plus and you can make that plus. So 17 plus a plus 1 is the same. Okay, please keep that in mind because that happens for all of the ones that are negatively charged. So if your atomic symbol is P with a minus 3, I'll do one more example. P is 15. That means 15 protons. If I take a look for the mass number, the atomic mass is 30.9 something, which means I round up to 31. 15 minus 31 is 16 for the number of neutrons, and the number of electrons is 15 minus a minus 3, which equals, again, 18. Notice 18 pops back up again, okay? I'm going to flip ahead now. Go ahead and try a couple of those on your own. I'm going to flip ahead to this one and show you how to do this one. So this is actually only just a tiny bit more complicated than the other one, even though it looks pretty much different. So let's go through. If you see, like they did aluminum for you already with the +3, the charge is very simple. Like anything that's in the upper right-hand corner is going to be the charge, so you can put a +2 or a -3 in right away. The number of protons for phosphorus, we just did this one. Number of protons is found on the periodic table. That's 15. That's the atomic number. The number of electrons is exactly the same, 15 minus a -3, which is 18. Now, how did these 18 electrons fall outside of the nucleus for phosphorus? There's 18 electrons. The first two always fall in the first, what we call first energy level. So here's what it looks like. So 2 in the first energy level, 8 in the next energy level, 8 in the next energy level after that, which would be the third energy level, and then 18, 18, 32, and we won't have to go past that. So how many energy levels? I know I'm saying energy levels. You guys are like, what are energy levels? They're just simply places outside the nucleus where the electrons tend to congregate. So the first energy level is very close to the nucleus and can only hold 2 electrons. The next one is further away, which means it's bigger, which means it can hold 8. The next one after that can hold 8, and there is actually a pattern here. Now, I know I have this with this pattern that I just wrote right here. It looks like I have a whole ton of electrons. Well, I only need 18. So if I add 2 plus 8, like this, and then that's 10, plus another 8 equals 18. So for phosphorus, I have 2 in the first energy level, 8 in the next energy level, and then 8 in the third energy level, and that equals the total of 18. So what electron configuration is this like? Take a look at 18 on the periodic table. What element is 18? If you look on the periodic table, the element is the noble gas argon. Now, if you have a negative for a charge, that negative then means that you have a larger ion than when it was just an atom. So minus charge is larger, and plus charge is smaller because we're getting rid of electrons when it's a plus charge. And for a negative charge, we're adding electrons on, which makes the atom bigger. It makes sense. It makes the atom bigger. Okay, so for strontium, I got a +2. What is strontium? Strontium's number 38, so I go 38 here. Number of electrons is 38 minus a +2, which is 36. Remember that for the number of electrons, we're taking the number of protons minus the charge. Okay, that's how we get that. How does 36 work? Well, the first 2, now I have 34. The next 8 I put in, now I have 26. The next 8 gives me 16. 26, that would be 18. And then the last one is 18. Remember, 2, 8, 8, 18, 18, 32, and so on. So 2, 8, 8, 18, all of that adds up to 36 electrons. So what's 36? On the periodic table, krypton is 36. This is a plus charge, which means that we have a smaller ion than we do the atom. Okay, see what you can do with that. I hope you can do fine. Remember, if you're given something like this where you have the number of protons, look on a periodic table. You will find magnesium there. Please don't forget to put the charge in, magnesium with a +2. That's where the +2 comes from. Number of electrons would, of course, be 10 because 12 minus a +2, and that would just be 2 and 8. Okay, there. You can do the rest of that. You can do the rest of that. I hope I made this all clear for you.